In the entry deterrence game of graph 24.4, we assume that the existing firm's decision to set a low or a high price is irreversible. This may be somewhat reasonable in some contexts, where there's a real cost to changing prices, or whether the firm has to plan for its capacity as it plans which price to set. But it may also be the case in other settings that firms can revisit the decision of whether to price high or low. We'll consider a game that models this here. Continuing with the initial setup from graph 24.4, we assume that if the existing firm sets a low price and the potential firm does not enter, the existing firm makes a profit of 20 and the potential entrant makes a profit of 0. But now we'll assume that the existing firm gets a chance to revisit its pricing decision if the potential firm enters. If the existing firm continues with its low price, we'll assume that the profits stay as they were in graph 24.4, a profit of 10 for the existing firm and a profit of minus 10 for the entrant who has to pay the fixed cost of entry. But if the existing firm now switches to a high price when the potential entrant has become a real competitor, the existing firm's profit goes to minus 10, while the new firm gets a profit of positive 10. If the existing firm instead sets a high price in stage 1 and the potential firm does not enter, the existing firm finds itself in its ideal position. Just as in graph 24.4, it then earns a profit of 30, while the potential entrant earns a profit of 0. But if the potential firm enters in response to a high price set by the existing firm, then the existing firm now gets a chance to revisit its pricing decision. If the existing firm continues with its high price despite the fact that the potential firm has become a real competitor, its profit will become minus 10, whereas the new firm will earn a profit of positive 10, just as in graph 24.4. But if the existing firm now switches to a low price, it will earn a positive profit of 10, whereas the new firm will earn a profit of minus 10 when taking into account the fact that it still had to pay the fixed entry cost to come into the market. In exercise 24a.14, you're asked to solve for the subgame perfect equilibrium of this game. To do this, you want to start at the bottom of the game and solve up. Look first at the third stage, where the existing firm gets a chance to reevaluate its pricing decision after it observes entry of the potential entrant. In both cases, a low price results in a profit of 10 for the existing firm, and a high price results in a profit of minus 10. Thus we know that in the third stage, the existing firm will choose a low price. We can now move to the second stage of the game, where the potential firm decides whether or not to enter. Given what we've just learned about the third stage, the potential firm should know that if it enters, the existing firm will respond by setting a low price, and this in turn will lead to a profit of minus 10 for the potential firm. The potential firm can get a profit of 0 by not entering, and so in the second stage, the potential firm will choose not to enter, regardless of which information node it has reached. Moving then to the first stage of the game, the existing firm knows that regardless of which price it sets, the potential firm will not enter the market. Thus, the existing firm is free to set a high price and get profit of 30, knowing that the potential firm will not enter. We then see that the entry deterrence that emerges in the subgame perfect equilibrium of graph 24.4 disappears when the existing firm can issue a credible threat that if it observes entry, it will set a low price.